Good afternoon, students. We have been solving internal flow convection problems. The morning class, we have solved some problems. Now we'll solve few more problems. Let us take this problem here. As you can see in this problem, it's a lubricating oil problem. First of all, it is a lubricating oil problem. And the temperature of it is given, and next thing you should identify that it is an internal flow problem. There is a tube, so it will be an internal flow problem. Once you find that it is internal flow problem, the next step is to find out the temperature of bulk mean. That's what we have to do. So that we will do once we write given, we can do that. Let's write what is given in question. T inlet is equal to 60 degrees centigrade, and the diameter is given as 1 centimeter, and the velocity is given as 3.5 meters per second, and temperature of the wall is given. Temperature of the wall is given as 30 degrees centigrade, and it is maintained constant is given, and is asking you to find the tube length to cool the oil to 45 degrees centigrade. So your outlet temperature will be 45 degrees centigrade. So this is what is given in question. So using this data, you will understand that this is T in and this is T out. So when I do T in plus T out by 2, what I get is bulk mean temperature. So 60 plus 45 by 2 will give you what? What is this? 100 not 5 by 2. So it is
52.5.
52.5 degrees centigrade. That is temperature bulk mean. Okay. Now that you know temperature bulk mean, you start writing all the properties at 52.5 degrees centigrade. Okay. So now, which material you have to take now? You have to take it for the lubricating oil in the data book. So go to the materials in the data book. Sorry, go to the property values of liquids and keep searching in page number 33. Page number 33, you'll be finding something called as engine oil. Can you see that? Here it is, engine oil. Is it visible to you? All the properties of engine oil. Engine oiling is nothing but lubricating oil. Both are same only. Okay, engine oil is a layman language. Lubricating oil is a bit of higher kind language. Anyways, both are same. That's the point here. You have the value as 52, and you have it for 40 and 60 here. So you have to do interpolation and get the remaining all other values here. Right. So once you know the bulk mean temperature, next thing to do is find out whether it is a laminar flow or a turbulent flow. So how to find out whether it is a laminar flow or turbulent flow? You have to find out the Reynolds number. So what is the Reynolds number formula? It is Vd by nu. So V is given in question, D is given in question, nu is unknown to you. Nu has to be bought out from the data book. So looking at the data book, you will understand that you have 40 for finding nu, 40, the new value is 241, it is 83, it is new, right? Yeah, new at the top. So 241 into 10 to the power of minus 6, it's 6, yes it is 6, then 60, it is 83 into 10 to the power of minus 6. Then you have to calculate it for 52.5. So what is the value? I have to get it. So do the interpolation fast. and tell me what is the value. Mm,
142.25.
The x value is
25
142.25 into
into
10
10
to the
power
power of
minus.
minus 6 meters square per second. Okay. Anyways, this is all rough work. You need not write all this in the original problem. Right, it is 142.25. 142.25 into 10 to the power of minus 6 meters square per second. Now let us write what is Reynolds number. Now the V value is given in question as 3.5 and the D value is given in question as 1 centimeter. To convert into meter, I'll multiply with 10 to the power of minus 2. New value, just now we got it by interpolation from the data book. So that is equal to what? You tell me. What is the Reynolds number value?
246.045.
24
246.045.
045.
246 points, sir.
246.045. Is that the value you got?
2460.4.
Or here point? See, it makes huge difference. Be careful.
246,
Huh?
246.04.
246 point or 2460 point?
246 points, sir.
246 is sure.
Yes, sir.
Let me check it. So it is 246.045. RE value is 246.045. Okay, that is the RE value. So what does that imply? The RE value is less than 2300. What does that imply? It implies the flow is laminar flow. Okay, so whatever the flow that is there here, it is a laminar flow. Once you know that it is a laminar flow, you will go to the data book, page number 132. Okay, page number 132, you will have these formulas here. RE is less than 2300, so you can use any formula that is there under laminar section here. This is a laminar section. Under this, any formula you have to use. So which formula will you use here? That is the important question. See, here majorly in laminar, you will have two cases. Number one is constant wall temperature case, and the other one is constant heat flux case. Constant wall temperature case and constant heat flux case. So here, if you look at this, the constant wall temperature case, you have this formula. If it is a fully developed constant wall temperature case, you have this formula. And if you have constant heat flux, this is the formula. Okay. Simply put, you use Nu is equal to 4.36 per constant heat flux and Nu is equal to 3.66 per constant wall temperature. Okay, so the problem that is given to us here, is it a constant wall temperature problem or a constant uh, heat flux problem? It is given constant here.
Constant heat flux.
Wall temperature is constant. So what you will do here, you will do that as Nu is equal to 3.66. You will take, so H into D by K is equal to 3.66. In this, what is unknown? K is unknown. K is not known to you. So you have to get it from the data book. How do you get it from the data book? Again, the same story. For 60, you have a value. Sorry, let's write for 40, you have 60, you have, and then for 52.5, you need. For 40, the value of k. This is last column is k value. It is third from the top. So this is 1, 4. So this is 0.1407. Is it 07? Yeah, it is 07. So quickly complete the interpolation and tell me what is the x value. 60 minus 52.5 by 60 minus 40 is equal to 0.1407 minus x by 0.1407 minus 0.1442. X value
0.1420.
fast 0.1420
125.
125, and the unit is watt per meter Kelvin. At the top, you write the value of K here. K is equal to 0.1427. Please repeat that. 1420125 watt per meter Kelvin. The K value is known to you now. So H has to be calculated here. Again, I'm reminding you, this is just a rough work. Don't write this. This is rough work, right? So the H value is unknown. D value, you know what is it? It's given in question as 1 centimeter, 1 into 10 to the power of minus 2 meter. By K value is 0.1420. 125 is equal to 3.66. Only unknown is H. Calculate the H value.
51.98.
What is it?
51.98.
5. Am I right? 51.98.
Yes.
Yeah, thank you. Watt per meter square Kelvin. That is the H value. But he's not asking you to find the H value in the question. What he's asking is, he's asking the L value. Okay. He's asking you the L value. How to get that? To get that, you will have to make use of the energy conservation principle. That is, Q is equal to Q. Q stored is equal to Q convected. You have to use mCp delta T. When I say mCp delta T, remember always that mCp and the delta T. Delta T means both the temperatures should be of the same material. In this case, it should be for same fluid. Okay, it is T in minus T out, whatever, higher minus lower, you will write here on this side. Coming to the convection, you know that HA delta T. Okay, what is this A? What is this A? This A is area with which the fluid is interacting. So this is T surface minus T infinity. So this delta T and this delta T are not same. Here on left hand side, both the temperatures are for fluid. Here it is for surface, it is for fluid. So there is a huge difference. Kindly note that. Okay, both delta T's are not same. Then how about this M? This is actually M dot. Okay, unless it is M dot, the unit will not get balanced. So it is M dot. So how do you get this M dot?
Rho
You
AV.
know, You know velocity here. So m dot is equal to rho a v you have to use. Okay. So I substitute that here rho a v into cp into t in minus t out is equal to h into a. What is this a here? Is this a on the
Ideal.
left hand side and a on the right hand side? Are they equal? A that you have here on left hand side, A you have here. Are they same? Area here it is referring to the volume flow rate or the mass flow rate. It will be measured with respect to the cross sectional area, whereas area on the other side is referring to the area with which the fluid is interacting. So this will be pi d L. That's the difference. See, this is very key thing, and this particular expression is very important thing. Many students do mistake here. Kindly learn this equation properly, understand each and every term in this particular expression properly. Most of the times, this kind of questions are asked in the examinations. So most of the time, students will do mistake with either delta T or area. So you should not do that mistake. I have explained it very clearly to you. The delta T's are for fluid on the left hand side when you use MCP delta T, and delta T is for surface and fluid on the other side. Whereas here on the left hand side, the area is cross sectional area pi by 4 d square, and the area on the other side is area with which the fluid is interacting. It is pi d L, right? So keep these things in mind. Now that you know this expression here, in this, do you know the value of T in? It is given to you. T out, it's given to you. What is the T in given to you in the problem? It is entering with 60 and should leave with 45. Okay. And then temperature of the surface is given. What is it? 30 degrees centigrade. Wall temperature is given. Okay. How about T infinity here? Tell me, what is the T infinity value?
10.
What?
Bulk temperature.
Very good. It's a bulk mean temperature, TBM, which is equal to 52.5 degrees centigrade. That is, here you are taking the temperature of the fluid, that is the average temperature of the fluid. Okay. So that's the thing on this side. H also is known to you. H just now we have found it out. What is the value? 51.98. And in this D, what is the D value? It is 1 centimeter, that is 1 into 10 to the power of minus 2 meter. So on right hand side, except L, everything is known. Okay, let's come to the other side. Here, the D value is again 1 into 10 to the power of minus 2. How about this velocity? Velocity is also known to you. It's given as 3.5 meters per second in the question. 3.5 meters per second is given in question. Now, come to the rho Cp. Okay, do you know rho? Rho, is it given in question? It's not given
Not
in question. So what you have to do? You have to use data book. You have to refer to data book and get it. How about Cp? Cp is also the same story. You don't have the Cp value directly in the question. So you have to get rho and Cp from the data book. So quickly do that. So rho, what is it? You have to learn doing this interpolation very fastly. Okay. The CP value here is this one. These two are the things to be taken. So for 40, it is 1964. For 60, it is 2047. 50, is it okay? Am I right? All the values are taken correctly, right? To get the value of x here for row. Similarly, for sorry, this
Two
is
zero
for
one
C.
five point eight seven.
Please give me a minute. This is actually for CP, right? This is for CP. The row I will write here. Row is this one. Row is 48 8, no, no, 876. 876. This one and this one. For 60, it is 864. For 52.5, you need. Yeah. Tell me, what is this? CP value.
2015.8.
2015.8. Very good. Row value
868.5.
868.5. And this is measured in kg per meter cube. This is measured in what? Look at the units here. Joule per kg Kelvin. Sometimes people confuse with kilojoule per kg Kelvin. That's why I'm showing you the units very clearly. CP units people confuse generally. So write those CP and row values clearly in this top right corner of your book or the paper, whatever. CP value, you tell me again. Somebody please tell me the CP value again.
2015.8.
2015.8 joule per kg Kelvin. Yeah, row value. What is it? Row value
868.
868 kg per meter cube. So you know the CP value and the K value now. The 868.5 here, and here it is 2015.8. 2015.8. So this is the expression here. Substitute all the values. Once you substitute all the values, you will get what is the EL value. Substitute all the values and get the value of L.
$56.13.
$57.4.
Sorry, I got muted. See, plus or minus 5% variation is valid. Okay, in all the questions, in all the answers, this is to be kept in mind. Some variation in answer is okay. Right. You have any questions at this level, or shall we move forward? Let's move forward. Right. Let us take up this question. This is the question. Right. Here we have atmospheric pressure, air. The first thing is air here. Next thing is it is entering a tube. It is a tube. So internal flow problem. It's an internal flow problem that we will see. Let's write what is given in the problem. It is given that the air is entering with 100 degrees centigrade and the diameter is given. The diameter is 0.04 meter and the velocity is given as 9 meters per second. Length also should be given, right? It's 2 meter. L is equal to 2 meter. Is given. A 1 kilowatt heater wound on the outer surface of the tube provides a uniform heat flux. So from this you can understand that it is a constant heat flux problem. The constant heat flux problem. So Q is equal to 1000 watts. 1 kilowatt means 1000 watts is given. And then what it's asking is, he's asking you to find the mass flow rate of the air, the exit temperature. Let me write here. M dot of air, what is it? That's the first question. The second question is T exit or T out, what is it? Both are same. And then T wall, T wall at the outlet, he's asking. T wall at outlet. This is bit tricky, I'll tell. So these are the three things he's asking you to find. So once you do all this, next thing to do is find whether the flow is internal or external. See, I am skipping the bulk mean temperature story here. Okay, why I am skipping this? Because the external temperature is not known, or T out is not known. T bulk mean is equal to T in plus T out by 2. But in this particular problem, T out is not given. Not given. So, and it is being asked actually. It is being asked in the question. So we need not take the bulk mean temperature story here. We can directly take the properties of air at 100 degrees centigrade itself. Okay, so all the properties of air, T in is equal to 100 degrees centigrade. So that means all properties of air at 100 degrees centigrade. Okay, so that's what we will do in this question. See, is it clear? if the bulk mean temperature is given in the problem, what you will do is you will be making use of the bulk mean temperature to find all the property values. But if it is not given, whatever the fluid temperature is given, that temperature you will make use of to get the property values. That's the point there, right? So next thing what to do, find whether it is a laminar or turbulent. How to find whether it is laminar or turbulent? You have to go for the Reynolds number, Vd by mu. You have to do V value is given as 9, D value is given as 0.04, new value you don't know, you have to get it from the data book. So from the data book, new value you have to get. So for that, what you have to do, you have to go to the data book, properties table, and what is the thing given to you here? What is the material here? Material here it is given as air. So for air, you have to go to page number 42. Remember this page number 42. Many times from air, the questions are asked. Page number 42. Let me rotate this properly. Yeah, here we go. For 100 degrees centigrade, you need values. So the 100 is directly available to you, so you need not go for any interpolation sort of thing. You can directly write the new value here. The third column is new. This one 23.13 into 10 to the power of minus 6. The same value you write here also. 23.13 into 10 to the power of minus 6 meter square per second. So write the RE value. Calculate and tell me what is the RE value now.
One
This
five
is the
five six four
question
point
mark. Please repeat it.
55
155 64.20.
64.20.
So what do you see? The RE is greater than 2300. That implies the flow is turbulent flow. Okay, that is the question, and that is the understanding about the question. So next thing is you have to find out the mass flow rate. He is saying, what is the formula for mass flow rate? M dot is equal to rho A V. You can use. So rho, do you know the rho value? You don't know. You have to get it from the data book. The rho value is 0.946. 0.946. Rho value is 0.946 kg per meter cube. Take it 0.946. The area is pi by 4 d square. Since this is rho AV, it is a cross sectional area that is to be taken. The area is pi by 4 d. The d value is 0.04 square into the velocity. It is 9. You get the m dot value. Tell me what it is.
0.0
What is that?
0.0106.
0.0106.
Yes, sir.
Yeah, it is m dot is equal to 0.0106. Unit is kg per second. This one he is asking you in the question. Right. So this is question A. Let's move to question B. What is asking in question B? Is asking you the exit temperature or the outlet temperature. So how to get this outlet temperature? Let us see. So for this,
Q stored. Can we use
what?
Q stored, sir?
Yes, you can make use of this Q here, but before that, you should have the H value with you. That is heat transfer coefficient value. Okay.
Nutshell 4.36 constant heat flux.
What?
Nutshell number 4.36.
See, 4.36 is for is for laminar flow. It is not for a turbulent flow. What we got here is a turbulent flow. You got it? So you cannot use that 4.36 here in the case of turbulent flow. That 4.36 is only for a laminar flow. Is it clear?
Yes, sir.
Yeah, thank you. So now you have to find out the H value. So which formula you will use from the turbulent this thing. See, from the turbulent, you can use this one itself. Okay, this is a generally used equation independent of thermal bond. So most of the times this will give you correct values. So we will take this Dittus-Boelter equation itself. That is Nu is equal to 0.023 into Re power 0.8 into Prandtl power 0.4 or 0.3 here.
0.4.
What? 0.4. Why? Why not
Heating.
0.3? Because it is a heating case. It is an electrical heater is there here. That electrical heater will heat this air. So this is a heating case. You have already calculated the Reynolds number. You have it with you. The Prandtl number should be taken from the data book. So let's go to the data book property values of air at 100 degrees centigrade. The Prandtl number is 0.688. 0.688 is your Prandtl number. So you're done with your right hand side. Move to the left hand side. It is H D by K. The K value is unknown. So how to get the K value? Again, go to the data book. Look at the K value here, 0.03210. 0.03210 watt per meter Kelvin. This is your K value. So you have Prandtl K with you. So simple thing next to do is substitute all of them here. H into D value is given as 0.04 by the K value 0.3210. Yeah, is equal to 0.023. Re, what is Re that you have found out just now? 1. Yeah, it is 15564. 15564.2 power 0.8. And the Prandtl, what is the Prandtl value? 0. Somebody tell me. 0.688. Prandtl power 0.4. H is unknown, tell me.
35.8.
H is 35.8.
79.
It's okay. 7, 9, and 8 are almost same. Watt per meter square Kelvin. See, are you sure with this Reynolds number value? I'm doubting about this Reynolds number value.
It is that only, sir.
Fine,
15564.
fine, then no issue, no issue. Leave it. So you got the H value, and what is asking you to find is the T outside. T out is asking you to find out. So how do you get this? T out
Q is equal to
is
H
not
delta
known. Q is equal to H A T surface minus T bulk mean kind of this is. Okay. So what is Q? The Q value is given as 1000 in the question. The H value just now we got just 35.8. A value is pi into D into L. D value is, what is it? It's given as 0.04. The L value is given as 2. The L value
Yes,
is
sir.
given as 2 meters. So this is your pi dl, and then you have T of the wall. Surrounding means the surface means wall. What is the wall temperature given in question?
Not
It's
given.
not. It's not given in question. So what else is given?
T in, sir.
T in is given. What is it? 100 degrees centigrade is given to you. Okay. This is the T in value. So what to do now? Yeah, you have to actually plug in. Before I come to this Q is equal to H delta T, I have to do Q is equal to MCP delta T. Q is equal to MCP T minus T, whatever the higher minus lower. Let me take this as 1000. M dot, you got it just now. What is the value? 0.01. Please tell me what is M dot value? 0106. Sorry, 0106. What is the CP value? The CP value is 1009. You write it here. CP is equal to 1009 joule per kg. To the CP value is 1009 into, among these two, one temperature is 100. That is known to you, and the higher temperature will be the unknown temperature, that is T outer minus 100. So from this, tell me what is T outer.
193.4.
193.4. This is what he is asking you to find actually, and this is taken in degrees centigrade. So you are done with your T outer. Okay, and what else is asking in the question? Wall temperature of the tube at the outlet he is asking. Now you use this temperature into this. See, since he is asking only at the outlet, only at outlet. So this you can take it as 193 itself. Okay, so that T wall you will get at outlet only. That is the exit. What is the temperature at the tube of the outlet? Okay, minus 193. You substitute, you will get T wall.
Sir,
Hmm.
T Bulkman will be 1.146.31.
Correct. What you are saying is right. I understand. Okay, let's do that also for a clarity's sake. Q is equal to H into A into T wall minus T bulk mean 1000 is equal to H. What is the H value? 35.8.
35.88.
35.8 into area pi into D is 0.04 into L is 2 meter into the T wall minus T bulk mean. What is the T bulk mean? Somebody said it now.
146.316.
Yeah, 193.4 plus 100 by 2. It is 140.
46.316.
46.31 degrees centigrade. 146.31. So T wall you will get from this. Tell me what is this T wall?
157.43.
157.43 degrees centigrade. See, this you can find out, but this he's not asking in the question. This is actually average wall temperature. See, because this is average because you have used bulk mean on the other side. Okay, but here in the question, he is not asking you the bulk mean or the average. In the question, what he's asking is he's asking only about the outlet, only at the outlet. That is temperature of wall at outlet. He is interested. You have to write the value of temperature at outlet. You got the difference? Is it clear?
Yes, sir.
Hmm? So this is what he is interested in this question. So tell me, what is T wall?
304.1.
304.1 degrees centigrade. Yeah, it can be this much, right? T wall at outlet. Is it clear? Any doubts you have? So this is actually B in the question. This is C in the question. This is the extra thing that we have done. Okay, this is not asked in the question. Sometimes, most of the times, so this is asked in question. Okay, most of the times, this is asked in the question. So till now, is it clear for all of you? See, apart from these three questions, I also gave you some more exercise questions here. You look at these exercise questions. You do these questions also in your practice. Okay, these two are for practice. Without any delay, you practice right after the class. Okay, these two questions you do it for yourself. They're almost similar questions. Okay, they are not great. If you practice these two, that will be of great help for you while doing the exams, while doing the problems in the exams.